on the phone from the caves of Mars, this week on Planetary Radio. Hi everyone, welcome to Public Radio's travel show that takes you to the final frontier. I'm Matt Kaplan. And yes, we will be on the satellite phone with a cave explorer, though he's not quite on Mars. Not yet anyway. Jut Wynne of the U.S. Geological Survey and Northern Arizona University will join us from the ultra-arid Atacama Desert in Chile, where he is learning to find caves from the air, hoping someday to do the same on the Red Planet. Bill Nye the Science and Planetary Guy puts us in an even more exotic locale next to a lake on Saturn's moon Titan. We'll also learn the ABEs of asteroids with Emily Lakdawalla, and Bruce Betts will help point out what's up in the night sky and help me give away another Space Trivia Contest prize. Do you know that it has been just over 2 years since the Stardust at Home project opened up its virtual microscope? Tens of thousands of you have been part of the hunt for tiny bits of interstellar dust trapped by the Stardust spacecraft. It has been a long, hard search. But now there's exciting news and an update at planetary.org. You may also want to take a look at Emily's blog, where you'll find a Phoenix Mars lander update and some Cassini images of Saturn's moon Enceladus that will make you feel like it is just beyond your fingertips. It just happens that Bill Nye is also excited about what we've found on another of Saturn's moons. Bill is a guest star on an upcoming episode of the television series Stargate Atlantis, along with Planetary Society President Neil deGrasse Tyson. He was shooting on location in the northwestern United States, but he didn't want to miss the chance to share some thoughts about Titan. Please excuse the marginal quality of the Skype connection, which was the best we could achieve from up there. I'll be right back with Jut Wynne in the Chilean desert.
Hey, Bill Nye, the Planetary Guy here, Vice President of the Planetary Society. The last couple weeks, it's been announced that there are lakes on Saturn's moon Titan. Now, if you're a science fiction buff, you might think, well, that's not so remarkable. What's the big deal? Lakes. Lakes, there's rain, and it flows downhill, and there's erosion and stuff like that. Oh, yeah, but there's a difference. These lakes are made of methane, natural gas, and ethane. And the reason you can do it with methane and ethane on this distant moon of Saturn is that it's so cold. It's minus 300 Fahrenheit, minus 180 Celsius. And so there you get the same features of the hydrologic cycle that we have here on Earth. It rains, that's precipitation. It flows down into a lake, that's collection. It evaporates back into the sky, evaporation, and then it condenses to form clouds, condensation. Condensation, precipitation, collection, and evaporation. It's a hydrologic cycle at minus 180 Celsius. It's astonishing. This really is the stuff of science fiction. Do you think that there are some sort of titanian microbes that have a whole life cycle associated with methane and ethane? And then it goes fantastically slowly because it's so cold. Who's to stop it? So, my friends, this is another thing where we send these robotic instruments to far-flung places in our solar system and make discoveries that just change our lives. To find lakes on another world with rain, a hydrological cycle on another world, could change the way we view our hydrologic cycle, our ecology, our environment here on our world. It's remarkable. Space exploration is so exciting. And we're doing it with extensions of ourselves, with these robotic explorers, my friends. Who knows what we'll find on the distant world Titan? Well, I gotta fly. Bill Nye, the Planetary Guy.
I first met J. Judson Wynne almost a year ago when he joined Chris McKay and a lot of other scientists in California's Mojave Desert. Jut, as he likes to be called, is a speleologist or cave researcher with the U.S. Geological Survey's Southwest Biological Science Center and Northern Arizona University. He told me how he and colleagues were learning to detect caves via remote infrared sensing. When he called me via satellite phone a couple of weeks ago, he was once again probing desert caves, but this time in the driest spot on Earth. The project is funded by NASA's Astrobiology Institute and managed by the Carl Sagan Center at the SETI Institute. Jut, that Iridium satellite phone is working great at the moment, but we want to warn people that these things tend to come and go. So let's start talking about what the heck you're doing down there, crawling through little caves and big caves in the deserts of Chile.
Could you repeat that, Matt? It broke up just a little bit.
Well, there you go. That's satellite phones for you. Now, just tell us, what are you doing? What is the goal of this team that is with you exploring caves in Chile?
Well, currently we have a 8-person team down here in the Atacama Desert of northern Chile. And what we are doing is we are mapping caves, we are exploring caves, and most importantly what we are doing is we are placing temperature and barometric pressure sensors within each cave. Now, the reason why this is very important for looking for caves on Earth, determining how to find caves on Earth, and then applying these techniques to looking for caves on Mars, is that we're able to model from the data that we collect within these caves how these caves behave thermally. And what we'll be able to do with those data, in addition to the measurements that we collect by mapping the caves, is we will be then able to model how these caves behave thermally and then use those data to predict the best times for conducting overflights to find these caves using thermal imaging.
Why is it going to be possibly so useful for us to know how to find caves from the air, perhaps when we're above Mars?
Well, unfortunately, they're not going to send me to explore a cave on Mars just yet.
Yeah, you and me both.
So exactly. So what we have to do is we have to figure out how best to detect these caves using a remotely sensed platform, because currently that's the only thing we have available to us. So by studying caves here on Earth, by actually physically being able to go into the caves and to be able to both study the structure, the geology, and the thermal behavior of these structures, and then be able to model when the most appropriate times would be to detect these caves on Earth, we can then take the data that we have collected here in the Atacama Desert, and we will also be collecting data in the Mojave as well. We will then be able to take these data and tweak it to Martian conditions, and then we can also model for Mars caves. So under what conditions would we expect to find caves on Mars? That's how we would do that, by taking the data that we have currently available to us right here on our planet.
Why the Atacama?
Well, the Atacama is a premier Mars analog site. We have high UV. It's a hyper-arid environment. For us looking for caves and wanting to best be able to characterize cave thermal behavior, because we're looking largely at the entrance when we're using a thermal imaging platform, it's good not to have a lot of obstructions in front of the entrance, i.e. vegetation. We don't have that problem here. I've probably counted maybe 50 bushes on the way from San Pedro to where we're currently at right now.
Wow.
There is very little vegetation here. It is a hyper-arid environment, incredibly stark vistas, and my gosh, everyone who has walked here has walked away saying, yes, I've now walked on Mars.
You know, when I was out in the Mojave with one of those groups of teachers, there was a guy with us who was from the Atacama, and as he walked around the Mojave Desert, he said, oh yeah, the Atacama makes this look like the tropics.
That was probably my buddy Armando, and yes, he is absolutely correct. By comparison, yes, the Mojave is the tropics.
So, these sensors that you are leaving in these caves, how are they getting their data back to you and to other researchers?
Well, we have to come back here next year this time to pull the data off of the sensors.
Wow.
They are programmed to log data for at hourly intervals. These HoboPro data loggers will then enable us to, once we come back in a year, pull the data off them. We will maintain them by, making sure everything's working correctly, exchange the batteries, put fresh batteries in them, and relaunch them for another year. And then we'll come back in year 3, and using the data that we have collected from year 1, we will begin modeling when to conduct the overflights for these caves.
Now, before we go any further, I want to make sure that we direct people toward your blog, which you are still, as we speak, doing entries in. Not just the great stories that you tell there, but these amazing photos of you and other people in these caves, squeezing through tight places, as you spelunkers are wont to do, but also apparently